Hi, and welcome back to Null0 Labs. Now, really and truly, we couldn't leave our journey of firewalls without actually touching a Cisco ASA and completing a high availability setup. So today, in the lab, we're going to have two Cisco ASAs and we're going to configure an active standby setup. I'm going to show you how it's done. So let's get in the lab and let's get cracking. So here we are back in our trusty firewall testing lab. And what I have done is I've configured two ASAs onto our lab environment. I have done two connections between the two ASAs. I've wired up 8 to 8, 7 to 7, and I've connected port 9 to our management network. And I've also added a Windows management PC. That will come into play later when we take a look at the good old-fashioned Cisco ASA ASDM interface. So a lot of this is going to be done in the command line to get the configuration up and running. And then we'll jump into the ASDM so that we can take a look at the GUI side of things. So from our previous labs, our external IP address has been this 192.0.2.4 address. We're going to continue to keep that. And our internal address was 192.21.20.254. The only difference is we're going to add a second IP address, .5 and .253 as our standby addresses. So there'll be an active address on the active device and a standby address on the standby device, and they will swap places whenever there is a failover. So let's jump on to ASA1 and start the configuration process. So here we are at ASA1. And we're going to do a lot of the configuration on ASA1 because once we've completed the configuration and we configured the failover interfaces, the configuration is going to synchronize to the standby device. So we don't have to do any major configuration on the standby device apart from the failover config. So now that we're on here, let's start with some of the basics. We'll get the basic housekeeping out of the way. Let's do our host name. So let's jump into configuration mode. Nope. We're going to set our host name as ASA-1. That seems good. We're going to set ourselves up a username of admin and a password of Cisco. Use something that's much more secure. A privilege level of 15. We're going to set ourselves an enable password. Again, don't choose Cisco, choose something more secure. So that's our basic config there. What we're going to do is we're going to enable logging. We're going to set our ASDM image, which we will use later. And that is on our disk 0. And that is ASDM 7.733, which is very old, but it's the only one that we can get to use straight away and access. If we use the ASA-V for this lab environment, it's very difficult to get access to the ASDM interface because of the 100 kilobit per second limit. Whereas with this is the old school ASA, we can actually access the ASDM interface and take a look at it. Right, so we have configured our ASDM interface. We've enabled logging. We'll enable logging in the ASDM as informational. So let's start configuring the failover configuration, and then we'll configure the interfaces. So we're going to start with failover configuration. Our failover unit LAN unit for this device is going to be primary. Just need to move my keyboard forward. I can't see it. There we go. The failover LAN interface, we're going to call it failover, and we're going to give that Ethernet 7. Okay. I'm going to set a failover key. This is the password, or just password for now. And then I'm going to set a failover link state interface. This is the one that's going to carry all the state information, and that's going to be on ETH8. And then failover interface IP for the failover is going to be 10.10.1.1 252, and the standby is going to be 10.10.1.2. Now we're going to do the same failover interface IP for the state, and that is going to be 10.10.2.1 255.255.255.252, and the standby is going to be 10.10.2.2. So that gives us those. Now we can go and configure our interfaces. But before I do that, let's do our interface. So we'll do int, let's do our outside interface, which was ETH0. And that's going to be name. We're going to name that as outside. It's our outside interface. We'll set the security level as 0. We're going to give it an IP address of, I said 192.0.2.4 255.255.255.0/24. The standby will be 192.0.2.5. And we will no shut that interface. So that gets our outside interface configured. The next one is our inside interface. This one here, ETH1. So int E1, again, name. It's going to be our inside interface. Its security level will be 100. And its IP address was 10.21.20.254/24 address. The standby is going to be 10.21.20.253. And we will no shut that interface. So that's our inside and outside interface configured. And now we're going to do our management interface, which is on ETH9. And I've given this a 10.1.1.1 network. So that's so that we can manage it. So int E9. Some other ASA devices will actually have a physical management interface, and it'll be management 0/0 or management 1/1. But you can also configure an actual interface to be a management interface. So name interface, we'll call this management. And we set its security level as 0. It's going to be a management only interface, and its IP address is going to be 10.1.1.1 255.255.255.0, and its standby address is going to be 10.1.1.2. And we will no shut that interface. Okay, so now if we have a look at our interfaces, show int IP brief, we can see our outside interface is configured with an address, our inside interface is configured with an address, our management interface is configured with an address, and our two failover interfaces are configured with an address, but they are administratively down. So we're going to enable those. So int E7, no shut. Int E8, no shut, because we do actually want our interfaces to be up. So there we go. So all of our interfaces that we have configured are up. Our host name is configured. Our enable password is configured. Our logging is configured. Our ASDM interface is configured. And our failover configuration is configured. So now let's configure our AAA authentication for that local user and enable HTTP access. So we are going to enable HTTP server enable, and we're going to allow HTTP from any IP address from the management interface. We're going to set SSH to version 2, and we will allow SSH again only from our management interface. If you wanted to lock this down to a specific subnet or host, you would change this and enter it here. Now we'll do our AAA authentication for our HTTP console, and that'll be local. And we will do the same for SSH. So we're going to use our username that we configured for authentication. So now let's configure our basic NAT. So we'll do our object network, and I'll call this our inside NAT. And I'm going to NAT our inside interface to the outside interface, and it's going to be a dynamic interface. Oh, I didn't create the object. So exit. Object network NAT network inside NAT, and that's going to be a subnet of 10.21.20.0, and the mask is 255.255.255.0. Now if I go back and we do the NAT, so object inside NAT network, and then we will do the NAT, and then we will do, yeah, perfect. Exit, and now we will do our route to the outside interface, our default route, and that will be going to 192.0.2.1, which was the VRRP address. So we will write that. Check our configuration. So we have our hostname set. We have our enable password set. We've configured our outside interface, our inside interface. We've configured our LAN failover and our state failover interface. We've configured our management interface. Again, if you have a dedicated management interface, this would be your management interface. We've configured our NAT, our inside NAT object. So we want to NAT this subnet, and we've enabled some logging. We've done all of our failover configuration. We've set our ASDM image. We've done our NAT rule, and we have done our route to the outside world. And we have enabled our HTTP and our authentication to use our local user account that we created. So that should be it for our main firewall. So all being well, we should now be able to connect to our desktop 7, and we should be able to send a ping to the internet, which we can. Good. So we have traffic flowing from our desktop through our first ASA, and we can check, we can show the translations, we can show connections, so we can see we've got traffic. Perfect. Okay, so that is our primary firewall configured and functional. But now, if I was to turn ASA 1 off, desktop 7 will no longer be able to access the internet, which is no good. So let's add our secondary firewall and get that all connected, and we will then be able to do a failover test. So I'm going to jump over to ASA 2. This has got no password. Again, I'm just going to show you that if I set a host name, I'm going to call this ASA-2. So we know that this is our secondary one. And all I'm going to do on this device is just configure the exact same failover configuration. So int E7, I'm going to no shut that interface first. No shut, not no shirt. Int E8, I'm going to no shut this one as well. So that's both of our failover interfaces ready to go. So we're going to go failover LAN unit. This one is going to be our secondary. So we know what it is. That's the only difference we're going to do. The exact same, and the rest of the configuration is going to be identical. So again, we're just going to do failover the LAN interface. We're going to call it failover, and that is going to be on E7, we said. Perfect. The failover key, we said, was just password. And then we set the failover link, the state interface. We're going to call it state. And that one was on E8. And then finally, we set the IP addressing. So the failover interface IP address for the failover was 10.10.1.1 for the primary 252, and the standby address was 10.10.1.2. And then we're going to do the exact same now, but for, oh, I think it should automatically copy the configuration over. Didn't even have to do that part. Right, so now if we do a show, if we exit out of here and do a show run, okay, we can see ASA1, it's changed the name, so that shows that it's bulk copied the configuration over. Outside interface is configured, inside interface is configured. Our LAN and state interfaces are configured. Our management interface is configured. Our inside NAT object, our logging, our failover configuration. You see, I didn't even get to complete this line because the configuration started to transfer. Our ASDM image, and what else have we got? Our HTTP enablement, our username and password, all synchronized. So that's everything synchronized. I'm just going to write that just in case I have to. So we now have two firewalls. So if we do show failover on the primary device, the one on the left, we can see that it is the host active, and it is monitoring the management interface, the outside interface, and the inside interface. We can see the standby is ready. It's monitoring the inside and outside. So we can see that we have it up and running. But so just to show some other functionality, if we do fail over, we hit question mark, we can reload the standby. So if I reload standby, now if I jump over to this standby, we can see we're now rebooting the standby. So that device will now restart itself, come back online, but obviously traffic is still flowing from our primary firewall. There we go, which is obviously ASA1 at the moment. So let's let this firewall reboot. We could also, if we wanted to make a firewall active, we could connect to it and do firewall active, and that will make the device that you're connected to the active device. You could do failover exec, and then say you want to exec this command on the standby, and you could then type a command and execute it on the standby device. So we could technically use failover exec standby and then go failover active. And that will make the standby device the active device, and it will take over. And I'll demonstrate that when we do a failover test. So whilst we wait for ASA2 to come back fully online, we will get ready to do some failovers. Right, ASA2 has detected its mate the primary firewall and it started to replicate the configuration. The primary device is saying that it's replicated to the mate. So if we show failover, we can see that the secondary is in bulk sync. So it's going through its synchronization state at the moment. And it is now standby and it is now ready. So we have both of our devices ready. So if we bring up our pings, if we stop that, let's send a fresh batch of pings through. So currently our traffic is going from desktop 7 through ASA1 through our redundant gateway to the internet. So let's cause a failover. So let's do, if we couldn't get a console cable or a connection to this one at the time being, let's do it from firewall 1. So we will do failover, and I'm going to say I want to execute this command on the standby device, and I want it to become the failover active. There we go. So we can now see that firewall 1 has now become the standby device. And if we jump over to firewall 2, log in, we can see that this host, ASA2, has now become the active device. So the secondary unit is now the active device and traffic is now flowing through there. So let's stop that. So it looks like we lost 2% of packets. So where did we see the drop? So 2 packets dropped, just doing a changeover. Let's send our ping packet through again. Let's jump back onto our ASA1, which is now the standby. So if we do a show failover, we can see that we are currently the primary device is now the standby. Let's make it the active again. So we can go failover, active. So we're now switching to the primary role. Show failover. This host is now the active one. And the secondary is now the standby, and it's both ready. So if we stop that again, probably 1 packet lost between that change back. Pretty good. Okay, let's do a full failover. So we're sending traffic. Firewall 1 is currently the active. It goes off. Not that one. We can see that we're not sending traffic at the moment. So we stopped at packet 7. Let's see how long it takes for it to fail over fully. There we go. We can see it's now switching to active. It's realized it's lost connectivity with its peer. Let's see that. About 58% loss out of 34 packets. So a little bit longer, but you know that within 10, 20 seconds, it's going to switch over onto the standby. Pretty good. Let's bring firewall 1 back online. And then we'll jump into the GUI. So we can have a look at the interface. You can see where we can see the failover information there. Right, we can see ASA1 has come back online, and because ASA2 is currently the active, it started sending the configuration back over to ASA1, which is good. Now I'm going to make ASA1 the primary again, just so that we know which side is the active. So I'm going to go into the command line. I'm going to do failover active. So this will switch ASA1 to the active firewall. ASA2 will become the standby. Now let's go and have a look at the management interface. Now, because this is an older version of ASA, I've had to use a Windows 7 machine with a older version of Java to get access to this. It's a bit convoluted. Obviously, with newer technology, you don't have to worry too much about that. If you have the physical ASA 5516s or the higher end 55 25s, 45, the newer models, you should be able to flash a newer ASDM image that you can access from a newer machine. It's just that the older versions of the software require TLS 1.0, and all modern operating systems nowadays have that turned off for security. So let's connect to Firewall 1, which is this one here, and this is the device that you will see when you log in. Now we can see here we have our interfaces. So we've got our inside interface, our outside interface, and our management interface. We can see our failover status listed here. If we click on details, we can see an output of the exact same information that we can see from the CLI, that this one is the active, the other one is the standby. We can see our link state interfaces up. So we can see everything here that we can via the CLI. Go back to configure it, back to the main page. We have our CPU, memory usage, our traffic status, and our logging, which is scrolling by when a traffic is flowing. Let's see if we got traffic still flowing from our test machine. Let's send some traffic out to 1.1.1, and there we go. We should start seeing that. We can see 1.1.1 is being pinged. There we go. We can see it's coming from our desktop 7. So we can see our ASDM syslog messaging here showing us our traffic. If we jump over into our configuration and we go to our device setup, we can see things like our static routes, which we did via the CLI. We can manage our interfaces. We can set our clock, our time, etc. We are in UTC. It is the 8th. That is about right for, yep, that's about right for UTC time. We can configure an NTP server if we like, which interface it should use to reach the NTP. Firewall, this is where we do our basic firewall rules, where we basically add our, from the inside interface, what it can access, what it can't access. Same for our management interface, our outside interface. If we add rules coming inbound for an inbound NAT, we would configure them here. Our NAT rules, this is the rule we configured on the CLI to allow traffic to be natted to the interface address of the outside interface when we were accessing the internet. Word of note, if you configure things and you leave the default rule in place, because by default, because our inside interface is a level 100, it can by default access anything that's lower. So the outside interface is a 0 interface, so it by default can access and go out of that interface. But ping traffic won't. So if we come into our service policies and click here and we go on our rule application, if we put a tick next to our ICMP, we'll be able to send that traffic through without having to create a rule here allowing ICMP traffic to the internet. What else can we show you in here? Our objects, this is where you create networks, subnets, hosts, addresses. This is our services. So if you wanted to create specific port services, you'd put them in here. We obviously have our local user database. Our device setup, we covered that. Firewall we've set up, we'll discard the changes. Remote access VPN, not going to be doing anything on that today. And our site-to-site VPNs. Our device management, here is where we can configure our rules of who and what can access our SSH interface, our management interface, and on what interface is our management interface. We can obviously set up copying of files, etc. Set up SNMP. You can configure your license codes, etc. if you need to. And again, we have our options here for our high availability in the GUI. So this is the GUI version of what we did in the command line, where we enabled failover, we configured our shared key. We didn't use IPsec because, again, most of the time your firewall devices are configured in the same rack and they're directly connected. So because they're back-to-back connected, there's no point in adding the overhead of encryption between the two. Interface 7 was our LAN failover interface. We gave it a name and the IP addresses. This firewall on the left is obviously our primary, and we configured our state interface. Again, we've got our interfaces here for our outside, our inside, and our management, and this is where we configured our standby IP addresses. We could also say if they were monitored. If we didn't want to monitor the management interface, we could hit that, apply it, hit save. Now, what that means is if I was to unplug the management interface from here now, it won't cause a failover. Whereas when they're monitored, if an interface goes down for any reason or it cannot reach the standby address via that interface, the firewall will fall over. Let's just enable that again. And remember to hit save. Always got to remember to save your config in the Cisco land. Again, we can hold down, change the times based on what we feel fit for our environment. For failover, we're not going to do anything here. The defaults are perfectly fine for our scenario, and we can configure custom MAC addresses that we may or may not want to use on our interfaces. Here we can configure our users. Again, as we saw, we can set up DHCP server. So if we wanted to have DHCP services running on our inside interface, we can do that here. Enable an address pool, the WINs, the DNS, the domain name, etc., like you would on any other. DNS, this will be for operating as a DNS client. So if we wanted to enable DNS for our firewall to be able to do DNS lookups, we add one and add a secondary. We'll do a Null0 Labs.net. We hit apply and we save that. If we jump back over to our firewall, we should now be able to do a NS. Or if we now do a ping to google.com, there you go. We can see we can now do DNS translation because we've now configured it. Not really going to touch too much in the advanced, you wouldn't need to. So here's the basics. So device management, where you can configure your DNS, DHCP server. If we wanted to do that, like I said, we say, right, we'll do a DHCP pool of 10.21.20.10 to 10.21.20.20. Our DNS servers will be 1.1.1.1 and 1.0.0.1. Domain name should be Null0 Labs.net. And that should be enough. We will hit OK. What I will do is hit OK, apply, and save. So that should now be our DHCP server configured. Let's test it on desktop 8. So if we jump to desktop 8, test 1, 2, 3. Now if we come up here and we'll set our device to use automatic addressing. We will hit apply. There we go. We can see it got assigned 10, 21, 20, 10, and it got assigned our 2 DNS servers that we asked for. Let's check to make sure that it has got network access. So ping to 1.1.1.1. Yes, it does. Ping google.com. Yes, it can. There we go. So so that should pretty much give you, oh, hold on, if we go to monitoring and then interfaces, we can see our ARP table. We can come to DHCP, we can see our client lease information. DHCP server table, there we go. We can see the IP address that we assigned to desktop 8. So we can get those statistics. We can monitor our routing. We can see our routing table. We've got our static route straight out to default. We can see our connected interfaces. If we'd set up any OSPF or any EIGRP routes, we would see them here. And we can make adjustments to our logging. So monitoring for anything that you want to see, diagnose, check is under here. Configuration is where we make the changes. Home is just where we start our mission from, and we can see all of our information on a dashboard. As you can see, it's not the prettiest of things. It's not the same as looking at a nice Palo Alto interface or a FortiGate interface for that of a matter. There's even some better open source interfaces. I hope one day Cisco will reach the realms of building an actual firewall which just has the configuration in the web interface, and we can easily do what we need to do without having to jump through hoops. So that is a ASA firewall setup using high availability, a failover link, a state link. We have our management interface and our inside and our outside interfaces. So I hope you found that useful. I'm off on a business trip for the next few days. Hopefully I'll get some footage of that to be able to show you that. Remember to like and subscribe. It helps grow the channel. If you have any comments or anything else, we have a community tab where you can leave some notes or ask questions. You can also follow me on the Instagram page and on Twitter, and I'll happily answer any questions or look for anything else, or take requests on board for what we could look at next. So hopefully soon we will finally get now into the routing of OSPF routing on the next video once I return. So have a good week, and I will see you on the next video.